In this video, I'm going to show you how to write out an electron configuration. We're going to learn how to do that using only the periodic table. So the first thing you'll see is that I have my blocks color coded. This is my S block, including helium. This is my P block, my D block, and my F block. When we're writing an electron configuration, we need to understand what each of the different parts mean. So the big numbers in front are called the coefficients. Those are going to refer to what row the element is in. The next thing we have is a letter, and that's going to be S, P, D, or F, and that's going to refer to which block on the periodic table it's in or which sublevel the electron is in. And then the last thing is going to be the superscript, which is just a number 1 through 10 or 14, and that's going to refer to how many electrons are in that sublevel. So let's use phosphorus as our first example. So I'm going to write out the electron configuration for phosphorus here as we figure it out. So first thing we need to do is find phosphorus. So phosphorus is right here on the periodic table. And what we're going to do is start at the beginning, start at element number 1, and work our way down, left to right, move down, left to right, move down until we get to phosphorus. So starting at hydrogen, we're in the first row, or the first energy level. The first thing we come to is the S block, so that's going to be 1s, and then we have to count how many elements are in the 1s. So let's count 1, and we can't forget about helium. Even though it's over there, it is part of the S block. So 2, so we have 2 elements in the 1s, so that's going to be 1s2. Since we've made it to the end of that row, we now have to move down to the second row. Since we're moving to the second row, we're going to write a big 2 there. So again, we're starting on the left and working our way to the right. So we're in the second row. The first thing we come to again is the S block. So that's going to be 2s. And we're going to count how many elements there are in the 2s. So in 2s, we have 2 elements. If we were to keep going, we would get to the P block. So we can't count those until we have a P written down. So there are 2 elements in our 2s. We're going to keep moving left to right. So if we go straight across, we now run into the P block. Remember, now we're still in the second row, so that is going to be 2p. And if we count over, we're now going to count again how many elements are in the 2p. So 1, 2, 3, 4, 5, 6. So there are going to be 6 electrons in the 2p. We're now going to go down to the third row. Since we're in the third row, I'm going to put a 3 now. Again, the first one I come to is always going to be S, so now we're in 3s. And if we count, we have 2 elements in the 3s. So we come across, remember these gray boxes are not elements, they're just telling you what column you're in. So we're going to go past all those and come back over here. And now we're still in the third row. Remember, this was 2p, so now we're on 3p. And we're going to count how many elements it takes to get to phosphorus, which is our goal. So we have 1, 2, 3. And we're going to stop at 3 because that's the element we're writing the electron configuration for. So this is our full electron configuration for phosphorus. There is something called the abbreviated or the noble gas notation of an electron configuration, and it makes it way simpler than this. So the way that works is you're actually going to find the most recent noble gas. So group 18, column 18 are the noble gases. So you're going to find the one that is in the row before the element that we're finding. So phosphorus is in the third row. So we're going to pick the noble gas in the second row. So the one before phosphorus would have been neon. And what we're going to do is put neon in brackets like this, just the symbol for neon. And so what that does is it takes place of the entire electron configuration for neon, which would have been this whole part right here. So it takes the place of all of that, since that is the electron configuration for neon. So it takes the place of all of that, and what we have left is what we have to write out. Let me do one more for you. I'll show you the long version and then I'll show you the short version. This time we're going to do arsenic, which is all the way down here. And I want to specifically do this one because it now includes the D block. Phosphorus was only the S and the P. So now let's do one involving the D. What you'll see is that I have this note right here that says that it's an arrow pointing to right here. And it says 3D. So that's just something we kind of have to remember, is that the D block starts in energy level 3, even though it's technically in the 4th row. So the order that ends up being is after 4S, we then have 3D, and then we're back at 4P. So 2P, 3P, 4P. So the D is always going to be -1, the energy level -1. So whatever row it's in, it's going to be 1 less for the coefficient for the row or the energy level. Let's start off making our way down to arsenic. We're always starting at hydrogen, and that's going to be 1S, 1, 2. We've made it to the end, coming back around to 2S, 1, 2. Making our way over, we're now in 2P, 1, 2, 3, 4, 5, 6. We've made it to the end, so we're coming back down to 3S, 1, 2, 3S2. Making our way over, we're now in 3P, 1, 2, 3, 4, 5, 6. Still got a way to go to get to arsenic, but we're at the end here, so we're gonna come back down. We're now in 4S, 1, 2. Remember, now we've reached the D block, so that means our energy level, our number in the front is gonna be 1 less. So instead of 4D, we're at 3D. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3D 10, but now we've reached the P block, so we're back to 4. P, counting only over to arsenic, 1, 2, 3. This is the full electron configuration for arsenic. Let's talk about the abbreviated one, or the noble gas. So we could have made that a lot shorter and easier if we just started at the noble gas in the row before. So arsenic is in the 4th row. So we're gonna go up to the 3rd row, and the last column on the right is argon. So I'm gonna put argon in brackets, and I'm gonna start after argon. So we've accounted for the whole entire first 3 rows of the periodic table, which means we can start right here. So we're starting with 4S, 1, 2, 3D, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and counting over to arsenic, so 4P, 1, 2, 3. So you can see that that's only this part. That's because this entire first part, sorry, just that part, that entire first part is what we're accounting for when we say argon. Both of these are perfectly acceptable electron configurations for arsenic.